Hi class, today we're going to learn how to solve for net force. The net force is the final force acting on an object after you add or subtract forces acting on the object. Just like you guys will have a job at one point in your life and you'll get a net pay of maybe $1,000 at one point, but you're going to net or result less than that. And the reason is because there's going to be taxes and insurance taken out. Well, same with our problems here, is that we're going to have forces that maybe add to an object, or we're going to have forces that take away, kind of like insurance or taxes from an object. So let's go ahead and solve 4 problems here, and you should be able to be comfortable solving for net force. This object right here on the left represents some object that is probably most likely falling here. It is got a gravitational force of 40 newtons downwards, and a friction force, maybe an air resistance of 10 newtons upwards. So we've got 2 forces acting on an object. Gravity is pulling down with a stronger force, but friction is trying to slow it down in a sense, and does that with 10 newtons of force. Since they are acting in opposite directions, you just go ahead and you subtract 40 minus 10, and you get 30 newtons of force pulling downwards. And we say that's in the y direction because it's happening in the vertical plane, just like on your coordinate plane in math class. The problem on the right, we're going to end up having forces vertically and horizontally a lot of the time. So in this problem, we have a 9 Newton force that is upwards. That's the normal force. And we have a gravitational force downwards of 9 newtons. And those actually are going to cancel out. Those will actually cancel out a lot of the time. And we get a net force in the y direction, the vertical plane, of 0 newtons. But if you look horizontally left and right in the x direction, there is a 12 Newton applied force to the right, and there is no force to the left, which means the only force, the net force in the x direction, is just 12 newtons. It's just it by itself. In the next problem, we have 4 forces on an object, and it looks like there's a 9 Newton force up and a 5 Newton force pulling down, which means we have in the y direction, 9 minus 5, we have a 4 Newton force that is being pulled upwards on the object. And in the x direction, we have 6 Newton force to the right and a friction force that is acting against that of 2 newtons to the left. So I would subtract 6 minus 2, and we get a 4 Newton force to the right. Over here, on the problem on the right, we actually have 2 forces pushing to the right. We have a 7 Newton force and a 3 Newton force, and that's equivalent to 1 force of 10 newtons to the right. And then we have a 2 Newton friction force to the left, so we would subtract those in the x direction. So 10 minus 2, and we get 8 newtons pulling to the right. And in the y direction, we have 8 Newton forces up, 8 Newton force pulling down. So you subtract those, 8 minus 8, and we get 0 newtons vertically. That is about it. Thank you very much.